Hey there everyone, welcome to the Unit 5 review. In this video I'm going over pretty much all of Chapter 4. Um, and so a lot of it is really, it's a really intensive graphing calculator chapter. So that's why I'm recording the video on my computer rather than on the iPad. So I do have everything written down, so I will be explaining it. So do make sure your audio is on, and then I'll be showing you it in the graphing calculator. So number one, I chose to solve using the quadratic formula, and this is why. So I see x squared plus 4x equals -5. You can graph that. Whatever's on the left side of the equal sign, you can graph into one line. So f1 says x squared plus 4x, and then whatever's on the other side of the equal sign, you can graph on the other side. So I typed in just -5, and you know you graph both sides of the equals sign on two different lines, right? And then you would get the intersection, but clearly there's no intersection here. Um, so because there's no intersection, I know I'm going to have an imaginary solution. Because I have an imaginary solution, I have to do the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I needed to get everything on one side, so I added 5 to the other side. Um, and so that got me x squared plus 4x plus 5 equals 0. A is 1, A is by the x squared, B is by the x, that's 4. C is the constant, that's 5. Plug everything in. X equals -b, so -4 plus or minus 4 squared for b squared minus 4ac minus 4 times a is 1 times c is 5 all over 2a, a being 1. So what I did was I typed this in, the discriminant part of it. So 4 squared minus 4 times 1 times 5, that's 16 minus 20, that's -4. So I got this, the -4. So what is the square root of -4? Simplify to get. Any negative square root has an I by it. So the square root of 4 is 2, square root of -4 is 2i. So I wrote -4 plus or minus 2i over 2. And then I just divided both by 2. -4 divided by 2 is -2. 2i divided by 2, those 2's would cancel, leaving behind just 1i. And that's everything on number 1. So number 2, similar problem. So I have 10x squared and then I have equals -10 plus 4x. So if I look at the graph, here's 10x squared. Here's the other side, -10 plus 4x. You see they don't actually intersect. All right. If they did intersect, it'd be really easy. We wouldn't have to do the quadratic formula. So like, look at number 1. Let's just say I changed the -5. I have a bunch of stuff typed in to a 5. Then I could easily do menu, analyze, intersection for my two answers. But because they don't intersect, you're going to have imaginary answers. So if they're real answers, the calculator is great with it. But if they're imaginary, you need to do the quadratic formula. So get everything to one side. I plus the 10 over, I minus the 4x over, and I wrote it all in order. So 10x squared minus 4x plus 10 equals 0. So A is 10, B is -4, C is 10. Okay? So plug in the formula. X equals -b. B was already negative, so I wrote a +4. Plus or minus the square root of b squared, -4 squared, minus 4ac, minus 4 times a is 10, c is 10. So this all makes -384. This is 16 minus 400. All over 2a. Sorry, I skipped that. 2 times 10. A is 10. So that's 20, right? All over 20 now. So back to the -384. So that's a big number, and I can tell you on the test the numbers won't be as big. So if you just got to this point, just pull the negative out and put an I there. Frankly, I'd be okay with that since the number's so big. But I do know how to simplify this, so I will talk about it. So how would I simplify the square root of 384? You need to think of your perfect squares. So like graph x squared and then pull up the table. And then, so 384 is a big number, so I'll start with some big numbers. So you could start with dividing it by 324, dividing it by all these. And so what I found was when I did 384 divided by 64, I finally got a whole number answer. So that's how I knew to simplify 384 into 64 times 6, because the calculator says divided by 64 equals 6. So the square root of 64 is 8. 8 squared, 64. So the square root of 64 is 8. So this I times the square root of 64 turns into an 8i. The square root of 6 will stay behind. And then these fractions just simplified. 4 over 20 makes 1 over 5. 8i over 20, that would make 2 over 5. If you're ever unsure about that stuff, just type it into the calculator. It'll spit out the simplified fraction. But yeah, that's everything. This is specifically the final answer. But like I said, if it's really big, I'd probably be okay with that. But I do encourage you to simplify the radicals. Okay, so that's everything on number 2. Number 3 is a multiple choice question. Which of the following systems best represents this graph? And I give you A, B, C, or D, right? Multiple choice, usually 4. So here's what I want to point out. This parabola is opening up, which means every x squared should be positive, or the answer should have a positive. So I would eliminate any negative x squareds, but there aren't any. But this graph, the line graph, is going down. So that means the linear function will have a negative slope. The number in front of the x will be negative. So on A, sorry if this is noisy, I'm at my desk. If A is negative, A has a negative in front of the x, that means that line's going to go down. So this is going to go up, this is going to go up, this is going to go up, because those all do not have a negative. They're all positive slopes. So by process of elimination, I know this is A. But let's say you weren't able to do process of elimination and figure this out. Look at the points of intersection. This intersects at negative 2, 0. And then if you look closely, you go across 1 and down 3. 1, 2, 3. So at 1, negative 3. So when you graph these two, you should graph your answer choice that you think it is. Remember, you don't need the y equals. So let's go to that one. So I'm going to graph it. X squared minus 4, and then negative x minus 2, negative x minus 2. And then I'll do menu 6, 4. Click, highlight, click. That's one of the points of intersection. And then menu 6, 4 again, get the other point. These are the same 2 points. That's how you know it's the right answer. Okay, so that's all there is to say about number 3. Number 4 is another graph one. Graph x squared plus 2, graph x plus 4, and then do menu 6, 4. So here's x plus 4, here's x squared plus 2. Again, you don't need to type in the y equals. So menu 6, 4, click, highlight, click. Menu 6, 4, click, highlight, click. Negative 1, 3, and 2, 6 are my answers. Negative 1, 3, and 2, 6. That's it. Number 5, how many real solutions does the system below have? What are they? So this one has no solutions. So if they did have solutions, you do the menu 6, 4. But look when you graph it. When I type in 2x squared plus 5 and negative 3x minus 4, they don't intersect. You could zoom out to, just to double check or, be super sure. But when you zoom out, you see they definitely do not intersect. So that means it's 0 solutions. Graphs can only intersect a maximum of 2 times, a line and a parabola. So we can do 2 times, 1 time, or 0 times. It can't be anything other than that, okay? So this one in particular intersected 0 times, so has 0 real solutions. Now, number 6 is name 3 possible solutions, and this is an open-ended question. So I kind of went about it this way. I went ahead and I graphed this. How do you graph it? You would delete the equal sign that's normally here. I'll show you on the scratch pad. You would delete the equal sign, and then you can type it in as a relation or y is greater than whatever it's given to you. So I did that for number 6, and then I got this graph right here. And so with this, I'm able to identify like 1, 0 works, 2, 0 works, or 1, 2 works. And then anything on the outside doesn't work. So these are some points that I picked that look like they were on the inside or outside. And then how you know for sure is just plugging them in and subbing them in. So like 0, 1 should work. Actually, I'm going to pause here and then I'm going to pick up in part 2 of the video. I do have to split these up into 2 parts because I'm using some free software with a 10-minute limit. So we'll finish this one at the start of the next video. Thanks.